Basics of Spring Security. Spring Security is a powerful and highly customizable authentication and access control framework. It is the de facto standard for securing Spring-based applications. Spring Security provides comprehensive security services for Java EE-based enterprise software applications. It handles authentication, authorization, and protection against common exploits. One of its core features is the ability to plug in various authentication providers with a default focus on username and password authentication. Authentication versus authorization. In Spring Security, authentication and authorization are core components. Authentication is the process of verifying who a user is, while authorization is the process of verifying what they have access to. Spring Security provides comprehensive support for both aspects. While there isn't a specific code snippet tied to the conceptual difference between authentication and authorization, understanding the roles they play is crucial. Authentication typically precedes authorization. In Spring Security, a user provides credentials, such as username and password, which are then verified by an authentication manager. Once authenticated, the user's requests carry their granted authorities or roles, which are then checked by an access decision manager that determines whether the user is authorized to access certain secured resources. Configuring in-memory authentication. In-memory authentication is a way to authenticate users stored directly in memory. This is mainly used for testing or simple applications where user details do not need to be persisted across application restarts. With Spring Security, you can set up in-memory authentication by configuring an authentication manager in a configuration class that extends Web Security Configurer Adapter. The code snippet provided sets up two users with roles user and admin. It overrides the configure method from the Web Security Configurer Adapter class to set up users in memory. The in-memory authentication method is used from the Authentication Manager Builder to define users. The withUser method is used to specify the username, password to set the password for that user, and roles to assign roles. These users are static and will exist for the lifetime of the application run. For this to work, you'll also need to ensure that the passwords are encoded or specify a password encoder. Otherwise, Spring Security 5 Plus will throw an error. Configuring JDBC authentication. JDBC authentication in Spring Security allows you to authenticate users against a database. You can use existing tables or custom schema for user details. Below is the setup for JDBC authentication using Spring Security. The provided code defines a Spring Security configuration class that extends Web Security Configurer Adapter. A data source bean is injected, which Spring Security uses to connect to the database. The configure method is overridden to set up JDBC authentication with the data source. Two important SQL queries are specified: users by username query to fetch user details, and authorities by username query to fetch authorities. HTTPSecurity is configured to require any request to be authenticated and to use form-based login. Custom UserDetailsService. In Spring Security, the UserDetailsService interface is used to retrieve user-related data. It has one method named loadUserByUsername, which finds a UserDetails object based on the username. Implementing a custom UserDetailsService allows us to define how user details are loaded, for instance from a database, an LDAP directory, a file, or other sources. The code snippet shows a basic structure for implementing a custom UserDetailsService. We define a new class, Custom UserDetailsService, that implements UserDetailsService. The loadUserByUsername method is overridden to include the logic for fetching a user's details. You would typically add database access here to find the user by username and create a UserDetails object to return. Spring Security then uses this UserDetails object for authentication and authorization processes. Password encoding. In Spring Security, password encoding is a vital aspect of securing applications. It ensures that passwords are not stored in plain text, which can easily be read and exploited. Instead, passwords are encoded using a one-way hash function, which makes it practically impossible to reverse engineer them. Below you will find an example of how to set up a password encoder using Spring Security. In the provided code snippet, we import the necessary classes from Spring Security. A security configuration class is defined, within which we declare a bean named password encoder. The method password encoder instantiates a new object of bcrypt password encoder, which is a widely used password hashing algorithm that includes a salt to protect against rainbow table attacks. The @bean annotation signifies that the method returns an object that should be managed by the Spring container. When the application starts, Spring will call this method to create an instance of password encoder, which other parts of the application can use to encode and decode passwords securely. Configuring HTTP security. In the Spring Security Framework, HTTPSecurity is used to configure security at the web level of an application. It allows you to specify the security features for the HTTP requests, such as which request matches which security constraints. Method security with @secured and pre-authorize @post-authorize. Spring Security allows you to secure methods in your application at the method level using annotations such as @secured and pre-authorize @post-authorize. @secured restricts method access to users with specified roles. @pre-authorize allows for more complex security expressions before method execution, and post-authorize checks expressions after method execution. The @secured annotation restricts access to the secured method to users with the role user authority. The @pre-authorize annotation on pre-authorized method allows access only to role admin users and checks that the supplied ID matches the authenticated user's ID. Lastly, @post-authorize in the post-authorized method verifies that the owner of the returned object matches the username of the currently authenticated user after the method executes. OAuth 2 and OpenID Connect with Spring Security. OAuth 2 is an authorization framework that enables applications to obtain limited access to user accounts on an HTTP service. OpenID Connect is a simple identity layer on top of the OAuth 2 protocol. In Spring Security, you can use these protocols to implement authentication and authorization in your applications. Let's see how to configure an OAuth 2 resource server with OpenID Connect in Spring Security. This line imports HTTP security from the Spring Security Framework, which is used to configure security aspects of your Spring application, such as specifying which paths are secured, configuring CORS, CSRF Protection, and much more as part of the security filter chain. JSON Web Token, JWT with Spring Security. In Spring Security, the integration of JSON Web Tokens, JWT, is often used for representing claims securely between two parties. JWT consists of three parts: header, payload, and signature. To implement JWT with Spring Security, you typically create a filter to validate the token for every request, configure a provider to authenticate the user, and update security configurations to use those components. The provided code snippet represents a custom username password authentication filter, JAuthentication filter, for Spring Security, which overrides the attempt authentication method. In this method, we would implement the logic to extract and pass the JWT from the request, validate it, and finally authenticate the user by creating and returning a username password authentication token. This filter is typically wired into the Spring Security filter chain to handle JWT validation for incoming HTTP requests. Remember Me Authentication. Remember Me Authentication, also known as persistent login, helps users stay authenticated between sessions without the need to re-enter their credentials. It uses a token stored in a cookie that allows the server to recognize returning users. Spring Security offers built-in support for Remember Me authentication. CSRF Protection. Cross-site request forgery, CSRF, is an attack that forces an end user to execute unwanted actions on a web application in which they're currently authenticated. Spring Security provides CSRF protection by default when using the Java configuration or the XML namespace. It does so by including a token in requests that can change state, which must be submitted back to the server, thereby ensuring the request was intentionally made by the user. In the code snippet, CSRF protection is being disabled, which is generally discouraged. This is done via the http.csrf disable method when configuring Spring Security. Disabling CSRF should only be considered for services that are used by non-browser clients, or for which there's another protection mechanism in place. Leaving CSRF protection enabled, which is the default, would require including a CSRF token in all patch, post, put, and delete methods, not including the code to enable CSRF, as it's already enabled by default in Spring security configurations. Understanding AOP. Aspect-oriented programming, AOP, complements object-oriented programming by allowing the separation of cross-cutting concerns, such as logging, security, and transactions. Instead of scattering these concerns across the code, AOP enables them to be modularized into aspects, making the code cleaner and easier to maintain. AOP allows us to define cross-cutting concerns in a separate place in our code, known as aspects. These aspects contain advice, code snippets, that are applied to various parts of the program, called Joinpoints, in a dynamic and non-invasive manner. This makes our application easier to manage and decouples concern-specific code from business logic. AOP terminologies, aspect, joinpoint, advice, pointcut, etc. Aspect-oriented programming is a paradigm that aims to increase modularity by allowing the separation of cross-cutting concerns. It does so by adding additional behavior to existing code without modifying the code itself. Below, we'll explore the core concepts of AOP, including aspects, joinpoints, advice, and pointcuts. In the code snippet above, we define an aspect named logging aspect, which is a modularization of a concern that cuts across multiple classes, logging in this case. Inside the aspect, we have a method annotated with @before, which serves as an advice. This advice is what Spring AOP will apply at a certain join point, which refers to a point during program execution, e.g. the execution of a method. The @before annotation indicates that the advice should run before the joinpoints method is executed. The pointcut is defined by the expression in the annotation, execution com.example.service, which tells Spring to apply the advice to all methods in classes within the com.example.service package. The joinpoint parameter passed to the advice method gives us information about the actual joinpoint, like method name in this case. Implementing aspects with Spring AOP. In Spring AOP, aspects are defined as regular classes annotated with @aspect. A key component of aspects is advice, methods that add extra behavior. For a demonstration, a logging aspect is implemented that logs method executions. The code defines an aspect using the @aspect annotation. Annotated with @component, Spring includes it during component scanning. The @before annotation defines before advice, executed prior to the matched method call. The pointcut expression, execution com.example.service captures any method execution in the service layer, allowing the defined advice to log a message before such methods are executed. This demonstrates cross-cutting concerns handling in a modular way, without modifying the existing business logic code. Spring configuration for AOP XML annotations. XML configuration allows you to define Spring AOP aspects by configuring the Spring Beans XML file. This involves defining the aspect bean, pointcuts, and advise that should be applied. In this XML configuration, we have an AOP config block where we define an aspect with the ID myAspect that will reference the simple aspect bean. We declare a pointcut with the ID myPointcut, using an expression that matches any method execution in classes within the com.example.service package. The AOP before tag is used to define advice that executes before the methods matched by myPointcut. The before method execution method, which is defined within the simple aspect bean, will be executed before each matched method. AspectJ support in Spring. Spring Framework provides support for integration with AspectJ, which is a powerful and mature aspect-oriented programming implementation. When using AspectJ with Spring, you usually define aspects using annotations. Below is an example of how to create a simple logging aspect using AspectJ annotations in Spring. In the provided code snippet, we declare a class logging aspect annotated with @aspect, indicating that it's an aspect class. The log before service method is annotated with @before and given a pointcut expression. This expression, execution com.example.service, is a Pointcut that matches the execution of any method within classes in the com.example.service package signified by the wildcard character. Before any matched method is executed, the code within log before service method will run, outputting a simple log statement to the console. Using AOP for transactions, logging, and security. In Spring, transaction management can be simplified using AOP to declaratively apply transactions to methods without having to embed transaction management code within business logic. The @transactional annotation is an AOP aspect provided by Spring. When applied to a method, it advises Spring to start a new transaction before the method execution and commit or roll back the transaction after the method finishes, depending on the outcome. Spring TestContext Framework. The Spring TestContext Framework provides a comprehensive testing functionality for Spring components. With annotations and support classes, it allows easy loading of Spring application contexts and the ability to cache these contexts across different tests. It also enables mocking and injecting of Spring beans seamlessly into test fixtures. This code snippet demonstrates how to use the Spring TestContext Framework to write a Spring integration test. The @runWith springrunner.class tells JUnit to run using Spring's testing support. Spring Boot Test is used to load the application context. @autowired injects a bean into the test. The test service method contains the test logic. Writing unit tests with Spring and JUnit. Unit testing is an essential practice in software development. It involves testing individual units of source code, such as classes and methods, to ensure they work as expected. Spring Boot simplifies the unit testing process with built-in support for JUnit, a popular testing framework for Java. In this example, we'll write a simple unit test for a Spring service class using JUnit and Mockito to mock dependencies. In this code, we define a test class myServiceTest with a test calculate method annotated with @test, indicating this method is a unit test. We use mock myDependency.class to create a mock instance of myDependency class, which myService depends on. We then stub the add method of the myDependency mock to return 5 when it is called with arguments 2 and 3. The service is instantiated with the mock dependency, and its calculate method is called with 2 and 3. We then assert the expected output using assert equals, which checks if service.calculate returns 5 as anticipated. Integration testing. Integration testing in the Spring framework involves testing the interactions between different layers of the application, such as the database, web layer, and service layer. Unlike unit tests, which focus on isolated components, integration tests verify that the various parts of the application work together as expected. Spring provides support for integration testing with tools like the Spring TestContext Framework, which allows for loading Spring application contexts and provides useful annotations and classes for tests. This example demonstrates a basic integration test in a Spring application. The @Spring Boot Test annotation tells Spring Boot to look for a main configuration class, one with @Spring Boot Application, for instance, and use that to start a Spring application context. The book service is injected with autowired into the test class, which allows for a test method to call its methods and assert expected results. The test when retrieving book then correct retrieves a book by its ID and asserts that the title is as expected, thus involving the service layer and likely the data layer. Mocking with MockMvc. In Spring, tests that involve web context usually require the ability to simulate HTTP requests and responses. MockMvc provides a powerful way to test web controllers without starting a full HTTP server. It works by creating a mock environment to perform requests and generate responses through the actual controller layer, thereby ensuring the MVC stack is behaving as expected. In the provided code snippet, the @WebMVCTest annotation is used to signal that only web layers should be tested. Your controller is the class under test. The MockMvc object is auto-wired into the test context. The test example method demonstrates how a GET request to /your endpoint is performed using mockmvc.perform. The results are then verified to ensure that the status is OK, HTTP 200, and the response content contains the expected string. This is done using chained and expect methods, which are part of a Fluent API provided by MockMvc for assertion. Testing Spring Data Repositories. Spring Data Repositories abstract the data layer, allowing for easier data access and manipulation. Testing these repositories is crucial to ensure data integrity and proper interaction with the database layer. Spring Boot simplifies this process through its testing support. Below is an example of how to write a test for a Spring Data repository using the Spring Boot test framework. In the code, @DataJPATest provides a dedicated test context focusing on JPA components. The Test Entity Manager is used to set up test data for our tests, while the user repository is the component under test. The actual test method should find user by email, creates a user entity, persists it to the database, and then tries to retrieve it using the repository method to ensure it works as expected. The assert that statements are used for asserting the conditions specified, such as the presence of the user and the correctness of their email. Testing Spring Security. Testing Spring Security involves setting up tests to validate security configurations, such as Authentication, Authorization, and CSRF protections. Spring Security Test provides annotations and utilities, making it easier to write security-related tests. Here we'll focus on testing a secured endpoint. Test configuration and profiles. Spring allows us to define different configurations for different environments, such as development, testing, and production, through the use of profiles. Profiles determine which beans and configurations are registered in the application context. During testing, you can specify active profiles to make sure that tests run with the correct set of beans and settings. Spring Boot test features. Spring Boot provides a powerful testing module that supports writing unit and integration tests for Spring applications. The @Spring Boot test annotation is commonly used to provide test-specific configurations, setting up the context needed to test Spring Boot applications. In the provided code snippet, @runWith springrunner.class tells JUnit to run using Spring's testing support. @Spring Boot test triggers loading of the application context for the test. This is an integration test that will start a minimal Spring Boot application. The whenLoad application then success method is an example test case that will use the application context provided by Spring Boot. This approach is great for end-to-end testing or when you want to test the entire Spring environment.